My name is Oliver Gierke. I work for SpringSource, and I'm the project lead of the Spring Data JPA module, and I'd like to give you an introduction to it today. I am lead of the JPA module. I'm also working at on other modules of the Spring Data project, like the Mongo one, and you just find some contact information here in case there's any questions we can't address in the Q&A session afterward. I would like to mostly work inside the IDE during that webinar, and just to give you a short introduction, I have a project prepared for you that you will find in GitHub. You will get the link in the one of the last slides, which will start with some plain JPA-based repository implementation, and we will start to introduce features of Spring Data JPA, and Shard can help you simplify the implementation. All right. So what you see here is just a regular STS Eclipse installation, slightly customized to my needs. Just remove all the views that I don't really work with, and the project you see over here is just the showcase example I mentioned. You can find on GitHub, check it out, build it, and most of the steps I will do in this demo here are inside this demo.txt and can be just proceeded if you would like to do it yourself again. What we have here is a more or less standard Maven project. More because you see the typical Maven project structure, you see the POM XML file. Less because I've added some additional resource folders just to have some code snippets prepared, not to bore you with typing and stuff like that. So the first part of the demo would consist of some code that we would like to refactor to introduce Spring Data JPA features. So why don't we have a look at what we start with first. The domain we start with is pretty simple. We have some customers and some accounts. So the customer is just a plain JPA entity. It has an ID field and is annotated with JPA annotations, right? Very simple, nothing more than that. The account belongs to a customer and has some expiry date. We will use that at later stages of the demo. And what I have here in the before package is the code that we will start with. And in the after package, I don't show you that right now, we will see where we end up finally. I've prepared two services here. To be precise, I wouldn't really actually see them or to be a service, because they're actually repositories or DAOs, if you want to say so. But as we were going to introduce a slightly better repository layer, I just had to find some different names, so just stick to service here. All right, so let's have a look at what the account service does. It just uses an entity manager, just plain JPA API, uses save to save accounts, and triggers a query here. So for the save operation, we have to, with JPA, we manually have to distinguish between persisting a new account versus updating an existing one. So we do this here using checking the ID, actually, right? See here. And for the finder method we want to execute, we set up the query, bind the parameters, and execute the result bit. I'd argue that most of that code here, can maybe overlap, with some logic, can be derived from the actual statement, but we will see that in the future. Beyond that, you see that we need a transaction to save the entity, which is what we're using Spring for already, and we annotate it with add repository to activate the persistence exception translation. Very same thing for the customer service implementation. We have a find by ID method that is using the entity manager, piping in the type. We have a find all method, so typical CRUD operations that we need to deal with in an application. We have some kind of pagination here, where we pipe in the page. So pagination essentially means we don't want to retrieve all the results, but just a certain slice of them. So let's say that the fifth page of customers by a page size of 20 or something. And we can do that with using JPA, of course, but we have to write some kind of boilerplate code to address that, right? Save operation is pretty much the very same thing as with the account. And finally, we combine both a query with the pagination side of things. All right. So very straightforward. And just to have something to execute here, I have some test cases. And I think I should be able to execute them. Just go this one. Run as tests. They should be green. Right. Okay. So I've already outlined some of the problems, which is mostly the biggest problem here is that we have to write quite some boilerplate code to get very, very basic stuff executed. There's not a real problem of the JPA itself, because I mean it's a rather generic API to store data into it. But for the typical use cases, you would either end up writing that a couple of 10 times. I mean, for each of your root entities, you would have to write some CRUD stuff, or you would come up with some kind of generic solution yourself, right? So which is what most projects do anyway. So why not come up with a generic solution that could be used by pretty much everyone using this library and putting some stuff on top of it. So to start now, I'd like to go back to the account service and now step by step introduce the repository abstraction we provide in Spring Data JPA. To do so, I just create an interface called account repository. Right. So Spring Data JPA ships with a variety of interfaces you can let your account repository extend from. You can even avoid that by using an annotation, but for the sake of simplicity, we just stick to the interface right now, and we extend CRUD repository. CRUD repository. We have to type it to the entity type plus the ID type here. And that interface is actually not Spring Data JPA specific one, but rather one from Spring Data Commons, and it contains quite a lot of CRUD operations like save, find one, exists, find all that stuff here. Right? Okay, so we do that and just stick to it right now. So if we now go ahead and say, okay, we would like to use the private account repository, called just repo, and auto-wire it into the repository. So we saw there was a save method on the repository, so we could just try to replace it with that one, just for the sake of simplicity. And we return that. Pretty much get rid of this stuff here. Right. So, and as I said initially, we could try to or just use that method and move that to the repository in the first place. Just go ahead. All right, just declare it in the first place. Let's see what we do with it, and then let that implementation return repo by customer. All right. So what do we do now? I mean, we could just try to rerun the integration test. It runs find by ID and runs find by customer, or just executes the second method here. So this one, we just delegate it to the interface. All right, just rerun that. So there's no bean of the account repository. So let's check the Spring configuration. Actually, haven't really taken a look at it so far. Where is it? Source. Oh yeah, there should be in main resources probably. Yes. There's an application in context before. So that's what we did so far, right? We just activated component scanning, and here in the infrastructure XML, it just contains some arbitrary Hibernate setup, stuff like that. So what we do now is just say, okay, we add a JPA repositories element and set that to the very same package. Close that one. And this way, enable the repository support of Spring Data JPA. And let's rerun the test. And now our test succeeds. So apparently, there's an instance of Spring Bean created that satisfies the account repository interface. And that's the first surprising thing. And the second surprising thing is that although we haven't defined any implementation, it can just execute the method here correctly. Right? So to explain you the first phenomenon is it's pretty much JPA repositories is working almost or in a similar way like component scan does. It just takes this base package and it specs it for Spring Data repository interfaces, which can be, or which we actually triggered by extending CRUD repository. As I already mentioned, you don't need to extend CRUD repository if you don't want to. It could be just plain repository interface, or you can use an annotation to do so. And it boils down to that interface being picked up by the Spring Data infrastructure and a proxy being created for it. So that's where we find the missing implementation, actually. Beyond that, the Spring Data repository infrastructure will take a look at all the methods declared in that repository and try to derive a query from it. So if you don't do anything manually, we just try to derive the query from the method name. So in that case, we would just strip away the prefix here, and then we find the customer attribute, right? And let's see, there is in the account class, where's the account class? We have this customer attribute. So this query essentially, so that check is also done at bootstrap time, that there really is a property called customer. And as we're done with the method name, we pretty much created the query from account A, where a.customer equals question mark. So that's pretty much it, and that gets returned. Okay. So what possibilities do you have to define methods here? You can have methods that return a collection of accounts. You can have methods return a single account, where the query, of course, has to return only one result then. And you can have arbitrary method parameters here. They are bound by position in the first place. If you want to be specific about the query to be executed, there's two ways, actually. You can either use add query and say from customer C, where C dot, no, we do it with for accounts, right? From accounts A, where A dot customer equals question mark, right? Organize and then do that. This way, we would do positional binding here again. You can also use named parameters like customer, but have to annotate the parameter with a param here and say customer. Unfortunately, we can't detect the parameter name here because go ahead that way. the parameter name is not available for interfaces in the JVM. It's only available for real methods, for implementation methods. So you have to use that one. And you see you introduce some kind of redundant information here, but if you have multiple parameters, it's safer for refactoring if you change the parameter position. That's fine. So the other way you could manually define a query is by using JPA named parameters. In that case, you'd have to define, if you want to do so, or in case you already have existing ones, you just annotate the entity with that named parameter, named query, not named parameter, excuse me, and then you say name, and the name has to match some pattern, and it's pretty much domain class dot find the method, so find by customer. And if such a name query exists, then let's try something cool. That query would be used. I mean, not very meaningful right now, but yeah, you can use those as well. All right. So we have that one. So okay, now I've explained how the actual finder method is derived. What about the save method? Yeah. So for the CRUD methods, so pretty much all methods that you find inside CRUD repository here, we have a variety of implementations. Pretty much for each of the Spring data stores, we have exactly one implementation. So there's simple JPA repository where we implement all the CRUD methods like delete, delete with iterables, delete and batch. There's some special ones here for JPA, but generally speaking, we have an implementation for the CRUD methods and add the query derivation mechanism on top of that. Right. Okay, so just to practice that again, let's do the very same stuff for the customer service input. So we create a new interface, customer repository. Let's do that. And this time, let's start with CRUD repository. Customer role. All right, so where's the implementation? We have it here. So we once again just do private customer repository repo and auto wire that into the class and replace that one with repo.find1. Yeah, so find a single instance by its ID. We return repo.find all. Okay, now you see the actual CRUD repository returned an iterable, which is due to the fact that we have to support stores that provide some kind of streaming access to data, and that's why we rather return iterable instead of list in that case. But there's two choices how you can work around that. It's either you can just redeclare the method. Let's say list customer. Yeah, go ahead. Find all. Just pretty much redeclare that method. And as the simple JPA repository returns a list, and it does so by definition. There we go. Find all. Yeah, it returns a list here, so it returns a stronger type actually. You can use the list actually. Another way is just to extend a JPA repository, which pretty much already contains the redeclaration of those methods and contains some special store-specific methods that you want to, or you might want to use, like delete and batch, where we build a JPA criteria query that does a single delete for all the instances. Right? So there's pretty much two choices here, and you can decide whether you want to expose the store information through your repository, which we typically recommend not to do that, but sometimes it's just pragmatism over correctness or theoretical correctness here. So we were stuck with the customer service until now we can just return the list here. Let's continue with the simple ones. Return repo.save. And yeah, okay, that's those pretty much. So what about the pagination here? Yeah? If you've read Eric Evans' book, Domain-Driven Design, you know about the concept of value objects, which are representing some concept of the domain. And in this case, for data access, pagination actually is a concept of data access. And that's why it actually would deserve some special type to transport the information. Because even if we restrict the subset of data we actually want to read, we return a plain list and pretty much lose all the information of how many pages there are in total, if it's the first page or the last page. And that's why we provide some API actually, or introduce those value objects in Spring Data. And what we have here is a pageable interface, which we can use. So you have a find all method taking a repo.find all pageable argument, which is pretty much defining the pagination information you request, and which returns you a page. And that's just the list with augmented with some metadata information like, are you the first one, and stuff like that. So we can hand in a new page request, as we call it, that we build from the page and the page size into it. And as we get back a page here, you see you could access the plain content, you get the number of the page, you get sorting information that you can also hand into the page request initially, of course, because paging is highly dependent on a defined sort order, of course. You get the total amount of pages and yeah, all that stuff. Right now, not to have to change the API here, I just go and pull out the content of it, right? So typically you would want to, if it was real refactoring I was doing, I'd probably expose the page here and take the page rule so that the client is not, or gets the more speaking API, so to speak. Okay, so let's find all for pageable so we can access all the entire data page by page. What about queries, right? So we could just take this one, just like we did with the account repository. We can just move that method here. And in that case, I go ahead and say, okay, this one takes pageable and returns a page. So that's pretty much the interface I actually would like to end up with. So as we're just writing an adapter right now, we can return repo dot we had find by last name, and we say new page request. Pipe in those methods and those parameters and say get contents to just fulfill the API of the service here. Right. So let's see if the test cases still work. Yeah, we have some pagination here executed, and there's some annotation. I think I have not retrieved. I think I have let the account still has. Nope, that was the wrong account. Showcase core. What was wrong right now? Hiding the traits and data. Oh, I think I have an invalid query left over somewhere here. Customer repository, account repository. Yeah, we can probably have to remove that one. So here that should be fine. Oh. Causal H. There's some check name query. Where did we put the name query actually? Oh, it's not saved. Oh, I probably had the that looks better. Okay, there we go. It wasn't fun if there wasn't going anything late, anything wrong, right? All right, so the test case now works, so we can execute the pagination, and at that point in time, it's pretty obvious from just looking at that class that our client could have used the repository directly, right? So we just delegate to the repository. So what we actually end up with, so we started with 2 interfaces and 2 implementations, and we end up with 2 interfaces that both contain a simple finder method, no implementation code in it. Okay. That, of course, is caused by the sample. I mean, there's probably, if you add more sophisticated queries, you will add query annotations, of course, and yeah, stuff like that. Yeah, you've seen the pageable and pagination working for the finder method as well. So we just detect a single pageable parameter within the parameter list and appropriately combine that. Yeah. So a second thing that we integrate with, or that we provide on top of that finder mechanism, is integration with a library called QueryDSL. And the QueryDSL allows to define predicates over those entities and dynamically execute them. The issue with those finder methods here is that in case you have quite a lot of queries, or even have queries that you would like to combine, so like predicates, you want last name and age and stuff like that. Of course, it's possible, like last name and age, in case that would work, so we could parse that. But the sheer number of methods can easily explode if you have a specific problem domain then. So to change that, there's this project called QueryDSL, which allows to define predicates, as I just said. And we provide integration via the account repository. We can let our repository extend the QueryDSL predicate executor interface. We have to type it to the domain class we manage and have a look at what this thing can do. It can execute requests and take predicate. Predicate now is part of the QueryDSL API. And we now have to find out how to create those predicates, how to start with that. And to do so, you add the QueryDSL dependency to your Maven POM. I did so. I just took 211 here, have a dependency in here, and then configure an annotation processor. There should be another spot in the POM, right? And there's this JPA annotation processor, and you tell it, okay, QueryDSL, please have a look at my domain classes, at my JPA entities, and generate meta model classes or query classes from them. It's a bit similar to what you find with the meta model capabilities of the criteria API, JPA 2.0 criteria API, but it generates a slightly nicer API, as we will see in a few seconds, and it's much more compact, and defining queries is much more compact and easy. So you see we've got a queue account and queue customer classes generated by QueryDSL, and they pretty much carry properties for our properties in our account class. but at a meta model stage, right? So what we can, what people now can go ahead and do is, where's the project? I had some snippets here, right? I had the a predicate class. This is what you would define depending on your business needs then. So you've seen that we have an account, or we had an account, which had an expiry date. So we would probably like to define the predicate of, is the account expired, as some predicate we can query for. And is expired can be expressed as expires before, and then we say take the current date. And what you see here is actual usage of the Cree DSL generated code. So I just use that $ as some reference to the root, and now you get type-safe references to your properties you have. So you can say account customer dot last name. It's a string path, and yeah, string path. You could go ahead and say, okay, this one equals foo, for example, and that would give you a string expression. Right, should be a Boolean expression, which you could return and use in your queries. Of course, you can combine those with AND and OR. Yeah, so you could easily come up with let's say, atomic predicates that can be combined into more complex ones. So in that case, I just hide this predicate behind some kind of static factory method here, just to let it be used nicely, and to name it so that you can use your the language from your business domain to then use these predicates from your client. So the client in that case is some helper snippet I have in my test case for the account repository integration test. Right. Where do we go? It's a bit puzzling. There we go. Showcase after account repository integration test. That's pretty much the same like we had before, just using the repositories directly. And I just add this test method here. Probably, no, that's fine. Account repository, we have to let that create user predicate executor. That should be fine. That's not applicable. How is it? Oh, I haven't saved it. One more time. Just do it right, and it works. Okay. So we can now define or execute a find all accounts that expire before this date, right? And we've set up the date. We have set up initially with 2 accounts initially, and one is expired and one is valid, and I just check that the expired one is in the result set and the other one is not. All right, and I try to re-execute that, and it just works. Okay. Yeah, that's the query DSL integration. So the benefits here is that on the one hand you have some type-safe possibilities to define your queries. So in case you change something in account, this class, the query class, will be regenerated, and you get red arrow markers here. There's no refactoring support currently, unfortunately, but you at least get notified when your queries break, right? When you reference something different. And I mean, using that factory method here, you can hide these predicate definitions behind even more meaningful expressions or phrases, right? In case you want to stick to the JPA criteria API, you say, okay, we want to stick to the standard as much as possible. There's a way to get some similar model as well with the criteria API, and that's what we call specifications. It's also a term derived from Eric Evans' domain-driven design book, and it pretty much gives you a callback interface to where you get the infrastructure components handed into, and you are just able to define a predicate here. So no need to create the root yourself, the criteria query. There's quite some boilerplate code you have to execute otherwise yourself. And I have an example prepared here that there's the showcase snippet Java. We should have customer specifications. Yeah. We want to find all the customers that whose account expires before a given date, and you can just, as I see, I mean, it's not really readable from a first glance that this stuff actually expresses the account expires before a given date. But the nice thing about the specification interface here is that you can actually hide the actual definition behind that simple method call. Where have I been? There. This one, right? So in the test case, custom repository integration test, we have this one here, find customers by specification, and the customer, nope, that was not it. Let me go this way. The customer repository now extends this JPA specification executor interface, which adds these find all methods for the specifications on top of it, right? In our implementation, our simple JPA repository implementation uses that or implements those methods as well, and that's why they can be used with the proxy. And we can now just define pretty much that method, find all, where the account expires before the expiry, right? It almost reads like fluent prose, and we have this where syntactic sugar kind of thing in here, which allows you to combine them with and and or. So you could just have, as I just mentioned for the query DSL predicate, you could come up with your atomic specifications, atomic predicates, and combine them on the fly using the API. So this is quite a neat approach to, let's say, predefined searches for something, where each of the search is can be implemented using such a specification, and then combined via a user interface or what have you. Okay, so this way you can pretty much avoid the explosion of query methods by just preserving full flexibility, and we mostly see people just placing all the specifications they use into a separate class, or some use that as the customer class directly, or just implement it there because it's just standard JPA API then accepts the specification interface. All right. Yeah. So that's it for the very first introduction, I think. I hope you got some insight. I think it's best if you just go ahead and check out the project and play around with it a little bit. There's some more snippets in here we unfortunately can't really get to anymore because of the lack of time. I'd like to go back to the slide deck then. Center, so we're back. So just to give you a recap on what we've seen so far, there's CRUD on steroids. You get some kind of so CRUD methods, most relevant ones actually, without the need to pipe in a domain type at all for every call, like you have in the entity manager. So it's a repository, it's a component managing persistence for a particular type, right? You get all the pagination with it. That's what the steroids actually are. And you get this pagination for the declarative query methods as well. So that's the second feature, actually. You have the ability to simply define query methods and then define how they should be turned into actual queries by some configuration means, but you don't have to write the boilerplate execution code for it anymore. You can get as complex as you like there. Even in the simple cases, the keywords and the syntax we provide with the query derivation mechanism should be sufficient. If you want to go more complex, then just add or write the query yourself and annotate it or define it through JPA named queries. You've seen the query DSL support specifications to define predicates over it. And there's quite a lot of other features we have there as well. We support auditing, which means you can capture who has changed an entity, and when was it changed an entity, when was it created, and who created it. So there's support there to plug in the let's say security infrastructure of your choice. So you would simply have to define who's the current user, and we will take care of the rest, right, through an JPA entity list management. There's also the possibility to integrate custom implementation code. Actually, stepping back, when we started, I said there was the expiry date here. We could come up with the idea that we want to bulk delete all of the expired accounts every night, right? And it's just there to simulate the need to do something more sophisticated than we can actually achieve with the finder method. Whether deleting the stuff actually is such a case, debatable, but we could try to come up with something. So what we do, or we have to do this is pretty much create another interface, which we define the methods we want to manually implement in. So in this case, I call it account repository custom, right? And we want to create an implementation. And in that case, I once again use the JPA criteria API to find all the accounts expired, and then just calling remove. I don't. It's probably not the most efficient way to do it, but just for the sake of simplicity, we get that stuff injected here. So we have a class that doesn't know anything about Spring Data. We have an implementation that doesn't know anything, or an interface that doesn't know anything about Spring Data. How do we get that stuff together? So we annotated with at repositories, so there should be an instance of it if Spring picks it up. To bring that stuff together, meaning the finder methods and the custom implementation, we simply let our interface extend the custom implementation interface, right? So we, as you see by the definitions here, we somehow pull together functionality. So we have the CRUD stuff declared in here, we have query DSL execution here, we have the finders declared here, and we have the implementation here. And doing so, we create a unique repository interface exposed to clients, right? So as you've seen, the custom interface here is package protected, so it's not seen by the outside world, and the implementation class isn't as well. Okay, so now let's simply go ahead and try to execute that method, right? And just copy that stuff into my account repository integration test. So I go ahead and have this account repository, and I try to call remove expired accounts. So I'll probably once again, where do we go? Account repository. Once again, I forgot to save. So that's pretty much it. And now we run the test case. And it's doing fine, right? And we should actually, that was the wrong shortcut. We should actually see that the delete statement is triggered here, right? So it seems to be invoked, the method, right? Now we actually do an assertion on it. So the question that this boils down to is, okay, how do these things, or how do they get connected actually? And it's configuration, convention over configuration again actually. So what we do with the namespace you saw here, where is it? It's application context. Before we actually went after, where is it? Source main resources. There we go. That element here actually derives a bean name for the account repository, which is account repository just with the lowercase a, and it tries to find a bean with the account with the name repository name info or ending on info in the first place. And if it can't find one, it tries to look up a class. So pretty much it would find account repository info because of the input suffix here, and declares, if it finds a class, it declares a Spring Bean for it and wires that to the proxy actually, so that the calls can be delegated. So if you stick to the info suffix, you're fine. In case you can't, there's of course the possibility to either say you define a special repository postfix, right? So you could go with something different, or you could easily go ahead and say, okay, I have a bean and say ID account repository info. In case you need that, need to manually configure that stuff, or want to just derive from the convention, right? So there's no hit the wall scenario in case you have moved executing your queries to the interface-based model and then suddenly realize, okay, we need to execute some implementation code. Okay, stepping back. Okay. Custom implementation code. Yeah, that's pretty much it right now. There is probably just step to the next page. Then you find the link to the examples here. It's a Git repository in GitHub. You can just download it, check it out, and play with it. There's more information about the Spring Data project on the project website. The project itself is also on GitHub, so in case you want to follow along, you have interesting feature ideas, you can file them to the Jira, or just go ahead and clone the repository and send us pull requests. The current version of the project is 101. We just released that, I think, yesterday or 2 days ago. There will be integration with Spring Root and the upcoming Spring Root version. So, so in case you're already working with Root, you get fully fledged support for all the stuff I've just shown here as well. And we're also in contact with the SDF team to provide you in IDE feedback about the query methods. So that you get support for just code completion support for defining the methods on the interface, or red arrow markers in case you you don't you have something wrong in your trade definition. Okay, so are there any questions? I think there are some questions I see in the Q&A session. There's one question asking about joins and where the mapping DDB structure is no exactly matching to the Java object. So if that question is targeting the query derivation mechanism, then the answer is that for nested traversals, like if you haven't seen one, but you can, let's say, traverse nested properties and objects, and we add some work out the appropriate joins there, depending on what property you traverse, just according to the criteria API as we use it under the hood. In case you want to go more, want to define more detailed stuff like what join types to be used and stuff like that, you'd better be off with defining the query yourself, right? Okay, so the safe method in simple JPA repository is not checking if the entity is detached right now. That's the question actually. So no, it's not. It's not checking it, and we don't have it on the roadmap so far. But you can easily just open up with Jira if you need to have that addressed, and yeah, so we'll have a look at it. The default behavior you've seen, the check for the ID being null, is just the default behavior. In case you want to alter that, there's an interface you can implement with your entity, which is called persistable, which will be called back. There's a callback method in there, is new, so that you could plug in other strategies how to detect how an entity is new, actually, right? We have yet another question about the possibility to different IDs in the database and the repository interface. So we actually support everything that's supported by JPA, so because we're just a layer on top of JPA. So the repository interface is typable, as you've seen, and your IDs just need to be serializable. You can't have embedded IDs. We just hand them straight through your JPA provider, and that should work. There's one issue in the Jira open for compound keys where you're not using an embedded ID object, but rather want to use the columns directly as properties in your entity. We will fix that for the upcoming 1.1 release, but you can use embedded ID right now or any ID type that is supported by your JPA provider. All right. Yet another question on, are we supporting NoSQL databases as well? With Spring Data JPA, we don't, because it's the JPA-specific module. With Spring Data in general, we do. So that's the idea, actually, to provide a repository abstraction on top of data stores in general, because that query derivation mechanism can easily be migrated and extended to the specialties of NoSQL stores as well. We have that stuff fully implemented for the MongoDB store already. So in the latest milestones, I think it was in milestone 4 of the 1.0 release was published last Friday, actually. And the stuff, pretty much everything you've seen here in this presentation is available for MongoDB as well. There's support growing for Neo4j. They don't support the query derivation mechanism, but the interface-based query approach is implemented there as well. You just have to define the queries using their Cypher query language manually right now, but we're heavily working on that, of course, as well. So you will see other stores supported by or supporting that model inside the Spring Data family as well. Thank you very much for attending on my side. You will get the recordings, as mentioned in the chat and on the slides, next week on the SpringSource website on youtube.com. The recording, the slides will be there. You get the project to play with, and hope you enjoyed it. Thank you very much.